In this video we have an electrical circuit where the cell has a potential difference of 24 volts. There is a 4 ohm resistor in series with 2 resistors in parallel, which are in turn in series with 3 resistors in parallel. The tasks are to calculate the current I1, the voltage V1, the current I2 and the EMF of the cell, given that its internal resistance is 0.8 ohms. The first thing to do in tackling a problem like this is to get the 6 and the 8 ohm resistor in parallel into an equivalent single resistor. Now, because there are 2 resistors in parallel, the equivalent resistance of those 2 will be equal to the product of them, 6 times 8, over the sum of them, 6 plus 8. So these 2 resistors in parallel are equivalent to a single resistor of magnitude 24 over 7 ohms. Now I'm going to look at the 3 resistors in parallel. Because there are 3 resistors in parallel, the product over sum equation cannot be used. As I've stated just now, that's only for 2 resistors in parallel. So for 3 or more resistors in parallel, this is the equation to use. So 1 over the total resistance equals 1 over R1 plus 1 over R2 plus 1 over R3 Therefore, for these 3 resistors in parallel, we have 1 over R equals 1 over 5 plus 1 over 10 plus 1 over 2. And this gives 4/5. So these 3 resistors in parallel is equivalent to a single resistor of magnitude. So to get R, you just turn the fraction 4/5 upside down. So the equivalent single resistance is 5 over 4 ohms. The initial circuit can now be replaced with an equivalent circuit of 3 resistors in series. So this resistance here will be the 4 ohms. The 2 resistors in parallel is equivalent to a single resistance of 24 over 7 ohms. And the 3 resistors in parallel is equivalent to a single resistance of 5 over 4 ohms. The resistance for the whole circuit can now be found. So R circuit equals, because these 3 resistances are in series, to find the total resistance we just add the resistances together. And this gives us an exact resistance of 243 over 28 ohms. Having done this, we can now think about finding I1. So using Ohm's law, which is V equals IR. If we rearrange this and make I the subject, I equals V over R. Therefore, I1 equals the potential difference of the cell, in this case 24 volts, over the total resistance of the circuit, which is 243 over 28, to give I1 as 2.765 amps. The next task will be to calculate V1. Now V1 in our initial diagram can now be replaced with the voltage across the 24/7 ohm resistor. So that is now V1. And we know the current flowing here is I1. So applying Ohm's law, we have V1 equals I1 times R. So that's going to give us the current I1 times the middle resistor, which is 24/7 ohms, and that gives a voltage of 9.48 volts. Now, to work out I2, the voltage across that parallel branch needs to be found. So I'm going to denote that voltage as V2 and put it over the equivalent single resistance, which is 5/4 ohms. So V2, again applying Ohm's law, equals I1 times R, which equals 2.765 times 5/4, to give the voltage across that resistor of 3.456 volts. Having found V2, it is now possible to find I2. So rearranging Ohm's law as I did earlier, I equals V over R. Therefore I2 equals V2 over the resistance concerned. So in this case, V2, which I've just worked out, over. Now, looking at the original circuit, the voltage is across the 5 ohm resistor, so 5 there. So the current going through the 5 ohm resistor is 0.691 amps. Now, to find the EMF of the cell, I said that the internal resistance of that cell, which I'm going to denote by little r, was 0.8 ohms. Now, the EMF equals the current flowing through the circuit, I1, times R circuit, or bracket R circuit, plus the internal resistance, close bracket. So therefore the actual EMF of this cell will equal now the total resistance of the circuit is 243 over 28 ohms, and the internal resistance of the cell is 0.8. So this gives an EMF of the cell of 26.21 volts. So due to the internal resistance, the actual potential difference that is available for the circuit is 2.21 volts less than the EMF. I hope again you have found this video interesting and informative. I will endeavour to create some more videos in the near future to do with circuits and also different properties, different topics in physics.